Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about sensor and measurement systems. So while active procedures can improve the measurement accuracy, that will impact on the object should be minimized to reduce the both potential harm and alteration of the measured quantities. The optimal level of active procedure is a compromise between the minimizing its influence on the object and also maximizing the measurement system performance. So we need to have an optimal level with minimizing its influence, also maximizing the measurement performance. Also, the signal sensors quantity is crucial to the overall measurement system to decide the quality and significant impact aspect of the signal to noise ratio. Sensor selection depends on the specific object quantities, so measured quantities like in signal amplitude, signal frequency, signal accuracies, and then practical constraints like in size, shape, material, invasiveness. So especially specified field like in biomedical instrument, these two are important. So depending upon that only we can select a particular sensors for our application. So because some application requires a high frequency, some application requires a low frequencies. So based on that only we can select the frequency. Similarly, amplitude range, sometimes we need higher amplitude variation, sometimes we may require small variations. And then how much accuracy is required, because accuracy is most important. Also if you go for a higher accuracies, the cost will be very high. Similarly, whenever you are going to fix that particular sensor, so we need to have that application where how many size will be available. So based on that only we need to select that. So we can shape up our sensor is most important, whether it will be able to fix it in that devices. Also which material used, that decides the performance, and invasiveness, that is insensitive to the noises. These are the some of the constraints that will be used to select the particular sensors. And then characteristic of measurement system, first one will be static characteristics. So for slowing changing the object quantities measured system, the output is primarily dependent on the current inputs. So where the direct input will be decides the outputs. So when time independent input output relationship, this relationship among that object quantity itself define the system static characteristic. So in static characteristic, output depends on the present input, that is a current input. So where previous inputs won't have that much impacts. So these are the important for a static characteristic: sensitivity, resolution, reproducibility, measurement range, linearity or non-linearity, and hysteresis. The first one, sensitivity. Sensitivity describes how much the measurement system output changes for the given change in the measured quantity. For example, measured quantity changing a small amount, but we are able to predict will be means that will be have a higher sensitivity. So it describes how the measurement system output changes, so depending upon a small variation in the input quantities. While higher sensitivity generally means that larger output changes with the smaller input changes. It is quantified the difference in variation of fields, either output per input or input per output. So we need a higher sensitivity for a small to detect the small variations. Second one will be resolution. So resolution is the smallest change in the measured quantity that produces and described change in the measured system outputs. So whenever we have small changes, that will be detected in the resolutions. So whenever we have a higher resolution, we get a higher clarity and higher better results. And higher resolution is represented by a small numerical value that has the same units and measured quantities. Reproducibility. So reproducibility qualifies the how consistently a measurement system produces similar results when repeatedly measuring the same quantity. It is expressed in the range within the successive measurement falls within the given probability, or we can say it is an above 95%. And narrow range of indicates a higher reproducibility. Repeatably, it is the smaller or a small change with that value, it will be have a higher reproducibilities. Measurement range. So the measurement range is a range of input value where the system can meet its performance specific for the constraint like in sensitivity or resolution. So it requires for a narrow range. So within that range, the results will be get and meet the required performance. In dynamic range, the range is divided by the resolution, shows the how wide range of input of the system can be able to handle it. It dimensionless, often described in the key of digital conversion. It affects the component choice like an A to D converters. linearity and non-linearity. So linearity describes how closely the measurement system input-output relation reassembles the straight line. So different straight lines, it can be used for differences. So least square feet are a line through the origin and end points, and zero-based linearity or proportionality. So these are the sum of the lines that refers the linear relationship. In non-linearity, the maximum deviations from the chosen straight line, it quantifies the lag of linearity. So high linearity, or we can say it's a low non-linearity, implies the constant sensitivity while the low linearities. It means that the input-output relation is not linear in response. That's why it says as non-linearities. Hysteresis. So this means that the output system can have a different output for the same input. So we expect whenever we apply the same input, the way output should be same. But if it is not satisfied, then it will have these issues. So this is normally due to the slow input changes. So for example, input changes slowly, the automatic outputs also changes very slowly. The result in a non-unique input-output curve, and that depends on the direction and range of previous inputs. So for example, the output is already close to the value, it automatically increases. For example, the input, previous output and current output is entirely changes. It takes some time to settle that value. It have various clues. It may have a mechanical backslash, or a material viscosity, or a magnetization, or a electrochemical element. This is the sum of the reason for this noise. So it introduces some independent of input changes. So it produces larger changes of the outputs. Thank you.